Alright, Braithen Productions brings you Spaceballs and its related physics concepts.
This presentation is brought to you by the one and only Greg McMillan.
Spaceballs is a 1987 parody film of the Star Wars original trilogy. Just like Star Wars, there are a lot of scenes that are impossible or would result in the deaths of someone or everyone on screen.
This presentation will cover the concepts of inertia, impulse, and pressure. Then, at the end of the presentation, we will discuss the plausibility of the scenes and whether or not the characters could even survive.
Now, trying to catch up to a certain space Winnebago, the Spaceball 1 jumps into ludicrous speed. This has been estimated by random people online to be 1,380 times faster than the speed of light.
Light speed!
No, light speed is too slow.
Light speed too slow?
Yes, we're gonna have to go right to ludicrous speed.
Ludicrous speed? Sir, we've never gone that fast before. I don't know if the ship can take us.
What's the matter, Colonel Sanders? Chicken?
Prepare ship! Prepare ship for ludicrous speed. Fasten all seatbelts. Seal all entrances and exits. Close all shops in the mall. Cancel the three-ring circus. Secure all animals in the zoo.
Give me that, you petty excuse for an officer. Now hear this. Ludicrous speed.
Sir, hadn't you better buckle up?
Now buckle this. Ludicrous speed. Go!
In this scene, we saw Dark Helmet initiate ludicrous speed and send the Spaceball 1 careening through space. Now, inertia is the idea that an object in motion will remain in motion until an outside force acts on it. When the ship jumps to ludicrous speed, Dark Helmet's body tries to remain in its original position. However, because he is gripping the railing, he is being violently pulled by the arms. This diagram shows this idea. As you can see, to start, neither are moving, but then as the ship begins to move, it pulls Dark Helmet by the arms, but not the rest of the body because it's not attached to anything.
Now we will see what happens after the Spaceball 1 comes to a complete stop.
And just stop this thing! I order you! Stop!
Here, let me help you, sir. Are you all right, sir?
Fine. How have you been?
Fine, sir.
Good.
It's a good thing you were wearing that helmet.
Yeah.
What should we do now, sir?
Well, are we stopped?
We're stopped, sir.
Good.
An impulse is a change in momentum of an object. Impulses occur during every impact and change in speed. The impulse that Dark Helmet experiences makes him go from a constant velocity to a complete stop. This crude diagram right here shows the impact of Dark Helmet. As the helmet comes into contact with the wall, it crumples. This crumpling increases the time of the impact, and therefore, the force decreases because the change in momentum will remain the same.
Another physics concept that should be present in this scene is the pressure exerted on Colonel Sanders. As he is sitting strapped in, the seatbelt needs to exert a force on his body to stop him. Unfortunately for Colonel Sanders, when a force is exerted, there is also a pressure applied, which is directly related to the area of the object applying the force. This even applies to the seatbelt of Colonel Sanders. Now, this diagram here shows how the seatbelt is not only exerting its force on the area touching Colonel Sanders.
Now let's discuss how this would actually work. For all of this, we are going to assume that the Spaceball 1 is starting from rest because we have no way to determine how fast they are moving, and it makes the math a lot easier. We estimated that the time it took for the Spaceball 1 to reach ludicrous speed was 19.7 seconds. Using this value, we can calculate the acceleration of Dark Helmet. After that, we use the mass of Dark Helmet's actor to calculate the force that Dark Helmet is experiencing from the ship. After doing all the calculations, we estimated that the force Dark Helmet would be is about 139 billion newtons. Although we have no evidence for this, we are going to assume that Dark Helmet's arms would be ripped clean off by the force.
Now, we estimated the time of Dark Helmet's impact was about 0.365 seconds. From this, we can calculate his acceleration during the impact, which is some absurd number, which is equivalent to 115 billion Gs. Using Rick Moranis' weight, we can calculate the force, which is then used for finding the impulse value. Another way impulse can be calculated is by taking the product of mass and change in velocity. Using this, Dark Helmet would need to travel at 13,077 meters per second for an entire year in order to reach the same impulse value. Now, using all this knowledge, Dark Helmet should be a fine red mist. It does not matter how thick his helmet is.
And using the seatbelt in Brooks's car, we were able to estimate the area of the seatbelt that stopped Colonel Sanders. Then, using the estimated time it took to stop, which was about 11.2 seconds, following the force calculation from earlier, we were able to determine the force to be 2.77 times 10 to the 12th newtons. Now, using the formula for pressure, we find that the seatbelt exerted a pressure of 301 trillion newtons per square meter. For reference, the Mariana Trench, not the Marinara Trench, or the deepest part of the ocean only exerts a 1.10 times 10 to the 8th newtons per square inch. Based on this information, the seatbelt would cut through Colonel like butter.
Now here are our citations.
And thank you for watching, Mr. McMillan. We hope you enjoyed it.
Yes, we do.
Please give us an A.